Let us see how to calculate sensitivity, specificity, PPV, which is positive predictive value, and NPV, which is negative predictive value. Let us consider a 2 by 2 contingency table. We always take DCs here, no DCs, and the test results are taken here, positive results. Here we take negative results, and here it is true positive. That means the person has the disease and the test results are also positive, so true positive. And this is true negative. That means the person doesn't have the disease and the test results are also negative, so true negative. And this is false positive. The person doesn't have the disease but the test results are positive, so it is a false positive result. And this is false negative result. That means the person has the disease but the test results are showing negative, which is a wrong result, so it is false negative result. We can take them as A, B, C and D. We can extend this table to a 3 by 3 table. Look at the first column. This first column gives you the number of deceased. Therefore, the total number who have the disease is TP plus FN. And look at the second column. The total number FP plus TN gives the number of people, those who don't have the disease. Now let us see the first row total. First row total is TP plus FP, which gives the total number of positive results. Now let us see the total of the second row, and it gives the total number of negative results, which is Fn plus Tn. This row total and this column total should tally. So the total will be Tp plus Tn plus Fp plus Fn, which gives the total population. Now let us see how to calculate the sensitivity. The sensitivity is the true positive rate. So to calculate sensitivity, we have to use the first column. It is a probability. So favorable cases are, how many cases are true positive over the total number deceased. So sensitivity gives the probability of positive result in who are deceased, which is Tp over the total, Tp plus Fn. So sensitivity gives the probability of positive result in the deceased, or we can say that it is the probability of detecting the disease, and it can be written as A upon A plus C. Now we will write the formula for specificity. Specificity is the true negative rate. It gives the probability of negative results in who are not deceased. So we are going to use the second column. Look at the arrow mark. Since it is a probability, we have to write the favorable cases in the numerator. So getting true negative are the favorable cases out of all cases, Fp plus Tn. All cases with no disease. And it is D upon D plus B. So specificity is the probability of detecting no disease, because we have used no disease column. Let us now see the formula for positive predictive value, which is PPV. To calculate this, we will be using the positive row, that is the first row. And look at the direction of the arrow mark. Therefore, the formula for PPV is Tp upon the total positive results, that is Tp plus Fp. This gives the probability of true positive results if the test result is positive. So we write the favorable cases by the total number of positive cases. We use only the numbers which are in the first row, or this can be written as A upon A plus B. Next we will write the formula for NPV, which is negative predictive value. We are going to use the elements of the second row and look at the arrow mark. The formula is Tn upon the total, Tn plus Fn, which is D upon D plus C. So negative predictive value is the probability of true negative if the test result is negative. So we have to use the numbers which are in the second row. This positive predictive value is otherwise called precision, and sensitivity is otherwise called recall. These two measures, PPV and NPV, are important measures for post-test probabilities. Sensitivity is the probability of positive result in deceased. It is the probability of detecting the disease. And specificity is the probability of negative result in not deceased. That is, it is the probability of detecting no disease. And PPV is the probability of true positive if the test result is positive. And NPV is the probability of true negative if the test result is negative. PPV and NPV are the important measures of post-test probabilities. An important measure of pre-test probability is prevalence. And formula for prevalence is number of people, those who have the disease, divided by the total sample, the total population. That is TP plus Fn. Total number of people, those who have the disease, is the first column total, which is TP plus Fn, divided by the total sample, Tp plus Tn plus Fp plus Fn. So this is the formula for prevalence. Another important result is sensitivity and specificity are inversely proportional. That is, if sensitivity increases, specificity decreases, and if sensitivity decreases, specificity increases. We can convert all these four probabilities, that is sensitivity, specificity, PPV and NPV, into percentage. Just we have to multiply by 100. This is sensitivity formula. If we multiply this by 100, it gives the answer in percentage. So to convert these probabilities into percentage, just multiply by 100. Sensitivity and specificity are fixed properties of a test. Sensitivity and specificity, they don't depend on prevalence of the disease. Whereas PPV and NPV vary depending on the disease prevalence. If prevalence increases, PPV also increases and NPV decreases. Whereas if prevalence decreases, PPV decreases and NPV increases. In some questions, the 2 by 2 contingency table will be given, and in some questions, we have to form the table. So to form this 2 by 2 table, some of the following things like sensitivity, specificity, prevalence, the sample size and the number who have the disease or number who don't have the disease will be given. If the sample size is not given, we may take the sample size as 100 and we may fill up the table. Now we will see the mnemonics used for sensitivity and specificity. Sensitivity formula is Tp upon Tp plus Fn. If Fn decreases, sensitivity increases, and if Fn increases, sensitivity decreases. For example, if we divide 10 by 2 and 10 divided by 5, this answer is 5, that answer is 2. If the denominator is smaller, the answer will be bigger, and if the denominator is bigger, the answer is going to be smaller. Similarly, if Fn is smaller, sensitivity answer will be greater. So, if denominator is smaller, the answer will be greater. The mnemonic used for sensitivity is SNOUT. SN, N, out. SN stands for sensitivity and N for negative result and out for rule out the disease. If sensitivity is 100%, say, that means Fn should be 0. If Fn is 0, no false negative results. So, all negative results are true negative. And sensitivity formula is Tp upon Tp plus Fn. Fn is 0. So, Tp upon Tp becomes 1, which is 100%. So, if sensitivity is 100%, Fn should be 0. Therefore, all negative results are true negative. Therefore, if the test result is negative, it is going to be true negative. Therefore, we can rule out the disease. We cannot rule in the disease. For that, we need a highly specific test. Similarly, specificity formula is Tn upon Tn plus Fp. If Fp decreases, specificity increases, and if Fp increases, specificity decreases. The mnemonic used for specificity is SPIN. SPP in. SP stands for specificity and P is for positive result and in for rule in the disease. If specificity is 100%, then Fp has to be 0 because specificity formula is Tn upon Tn plus Fp. Fp has to be 0 so that Tn upon Tn becomes 1, which is 100%. And if Fp is 0, no false positive results. So, all positive results are going to be true positive. Since all positive results are true positive, if the test gives a positive result, we can rule in the disease. And in this case, we cannot rule out the disease. To rule out the disease, we need a highly sensitive test. Let us learn the formulae for likelihood ratio, pretest probability, pretest odds, post-test odds and post-test probabilities. For likelihood ratio, we have positive likelihood ratio and negative likelihood ratio. Positive likelihood ratio formula is sensitivity upon 1 minus specificity, and negative likelihood ratio formula is one minus sensitivity upon specificity. So, sensitivity will be in the numerator, specificity will be in the denominator. We have 1 minus in the denominator for positive likelihood ratio and 1 minus in the numerator of negative likelihood ratio. And pretest probability is the prevalence we know. And prevalence formula is number of people, those who have the disease divided by the total number of people. Number of people, those who have the disease is the first column, Tp plus Fn divided by the total population, which is Tp plus Fp plus Fn plus Tn. Now, let us write the formula for pretest odds. It is prevalence divided by 1 minus prevalence. that is number of people those who have the disease divided by number of people those who don't have the disease. So number of people those who have the disease is TP plus FN, and those who don't have the disease is FP plus TN. If we substitute prevalence formula and take LCM and simplify, the denominators will get cancelled and we get TP plus FN divided by FP plus TN. Next formula is positive post-test odds. For pretest probability and pretest odds, we will be using the number of people those who have the disease and number of people those who don't have the disease. We don't see positive and negative results there because it is a pretest. Whereas for post-test, we have positive as well as negative. Positive post-test odds is pretest odds multiplied by positive likelihood ratio. Now pretest odds is TP plus FN divided by FP plus TN times positive likelihood ratio. Sensitivity is TP upon TP plus FN 1 minus specificity. Specificity is Tn divided by Tn plus Fp. Let us take LCM and simplify. Tp divided by Tp plus Fn divided by LCM here is Tn plus Fp. We get Tn plus Fp minus Tn. These two are getting cancelled and these two are getting cancelled. It becomes Tp upon Fp. So the formula becomes so simple after simplification. So we will write this formula as true positive divided by false positive. Similarly, negative post-test odds is pretest odds multiplied with negative likelihood ratio. Same way, if we write the formula of pretest odds and negative likelihood ratio and simplify by taking LCM, it gets simplified and we get Fn by Tn, that is false negative by true negative. Next formula is for positive post-test probability. And it is positive post-test odds divided by positive post-test odds plus 1. Same way we can simplify this formula. Positive post-test odds is Tp divided by Fp, and in the denominator we have Tp divided by Fp plus 1. We will take LCM. In the denominator, Fp is the LCM. We get Tp plus Fp. These two denominators will get cancelled. It becomes Tp by Tp plus Fp. So it is true positive upon true positive plus false positive. This is same formula as PPV. So positive predictive value and positive post-test probabilities are same. Now let us write the formula for negative post-test probability. The formula is negative post-test odds divided by negative post-test odds plus 1. If we write the formulae and simplify, we get Fn divided by Fn plus Tn. This is 1 minus negative predictive value. Look at this table. This table has all the formulae which we learnt now. And you have to be thorough with all these formulae.